Okay, let's get started. Hello, everyone. Thank you for joining us. My name is Mark Eaton. I handle sales here at PacGenesis. And today's webinar covers a common topic that we see with our clients, migrating data into the cloud. We're going to walk through some of the challenges in data migration and then review how the Aspera solution works. I'm joined today by Jason Warman. He's our VP of Technical Services here at PacGen. Jason will present a live demo of Aspera transfers going into the cloud, and then afterwards we'll open it up for a Q&A session. During the presentation, please feel free to submit questions through the chat feature. So first, a little bit about us. PacGenesis is an IBM business partner that focuses exclusively on the Aspera product line. All of us here at PacGen are former IBM Aspera employees, so we have years of experience with the product. We understand the technology, the licensing, and maybe most importantly, the use cases of how customers actually deploy the product. PacGen provides Aspera licensing sales, of course, but also professional services for things like installations, upgrades, and as well as training. We are the Aspera experts. So the issue with migrations is the data is enormous. We frequently see clients that have to move hundreds of terabytes or even petabytes of data. The problem is it takes a long time to move. I had one client in the media industry that needed to move a 300 terabyte archive from the US into China. They had calculated that with their current process, it was going to take well over a year. The problem is that most customers don't have a year. They usually have just a few weeks or maybe at most a few months to get out of a data center. So moving data very quickly is often critical. Now, with cloud migrations, if you're just moving, say, 20 terabytes of data into the cloud one time, you can probably get away with shipping hard drives, things like Amazon Snowball service. However, the use cases that we see for cloud migrations tend to be much more complex. One of the biggest ones we'll see is consolidation, where clients are uploading from multiple sites. Maybe they're collapsing several data centers into one and then uploading that into the cloud. There's a lot of coordination that's required to manage all of these different transfers. It's not one single transfer. It might be hundreds or even thousands of transfers going up from different sites. The other thing that we'll see is transfers between public clouds. We'll often see this where maybe we're moving workloads out of Azure into AWS. Cloud providers generally don't make it easy to get data out, so this is always a challenge. And then the last thing we'll see is that usually these migrations are not a one-time event, but more of a long-term process. There may be a pre-processing of data that's required before it can be sent, or maybe there's a post-processing procedure that needs to be done before it's ingested. Maybe it needs to be normalized before it can be loaded. Also, after initial upload, a lot of customers will continue to run their on-prem data centers and those cloud instances in parallel. As new data is generated on-prem, it's uploaded into the cloud, so it's kept in sync. And then after a period of time, they can cut over. The point is that these migrations tend to be more of a long-term process. Now, some of the ways that we see customers move data now, I had mentioned shipping hard drives. You know, the advantage of this is it's very inexpensive and you can move large amounts of data. The downside is it tends to be long lead times, and that includes the time it takes while the data is in transit, but also the time it takes to be loaded into the cloud storage. The other issue is these tend to work well for one-time transfer, but it doesn't really work well for these ongoing migrations that we often see where the data is uploaded in batches. The next thing that we'll oftentimes see is dedicated connections. These are sort of semi-permanent, low latency connections like AWS Direct Connect or Azure Express Route. The downside to this is it doesn't necessarily support multiple clouds. You'd have to have separate contracts for that. It might not be available in all regions that you're going into, and it might not be available in a private data center. The last thing that we'll see is the native tools that from the cloud providers. These are the multi-part uploaders. Very low cost or free. The advantage is they're available everywhere. They're easy to use. The problem is it's slow, and it can often take months or even years to complete these very large data migrations. So that leads us to the Aspera solution. And when we say Aspera, it's a suite of products from IBM that provides high-speed data transfers over the internet. It's a software-only solution, so there's no hardware appliances, there's no special networks required. It's purely software. I wanted to talk a little bit about how the Aspera technology works. And anyone that's ever seen an Aspera presentation is probably familiar with this chart. This 3D diagram illustrates the expected throughput for traditional TCP-based transfers, things like FTP or HTTP. Now, this back corner here, this column, if I can find my cursor, this would represent transfers within your data center. There's no latency, there's no packet loss. You're going to get very good throughput. The problem is that when you start transferring over a geographic distance, like going from a private data center into the cloud, you're increasing latency and the potential for packet loss. And both of these dramatically reduce the effective throughput of TCP. So if we can see here in this chart, a typical coast-to-coast transfer is about 80 to 100 milliseconds of delay. We can see here in this chart that with 100 milliseconds of delay, your effective throughput drops down over 90%. Really, can really slow down your transfers. Now, there have been some attempts to fix this, things like parallel streams or using compression. They don't really address the underlying issue though, which is TCP is overly conservative and it's inherently flawed for transferring data over distance. So rather than trying to fix TCP, what Aspera does is it replaces it entirely. It's a proprietary protocol that transfers data at full bandwidth, regardless of latency or network conditions. And the net result is very fast, predictable transfers anywhere in the world. The other thing that the protocol is doing is it's automatically encrypting the data in transit. So you don't need to encrypt it ahead of time and then send it across. It's done automatically in the protocol. Most of our customers are using commodity internet. You don't need special links for this, just regular internet. This chart will illustrate the performance improvements that you can expect with Aspera over TCP. So up top here, we can see the expected transfer times for typical TCP-based transfers. Again, this is things like FTP, where if you're sending a 10 gig file across the US, it's going to take about half a day. And that's regardless of how much bandwidth you have. Oftentimes we'll see customers that will increase their bandwidth in data centers, hoping to increase their transfer speeds. And of course, it doesn't do anything for that. They don't have a bandwidth problem, they have a TCP problem. Now, if we go out further to say Europe or into Asia, you can see the transfer times increase to the point where it becomes what we call impractical, meaning it's faster to copy it onto a hard drive and ship it with FedEx than it is to transfer with FTP. Now, down below, we can see the performance that you can expect with Aspera, where given the size of the file that you're transferring, say a 10 gig file, and the connection that you're on, say a 100 meg connection, we can tell you exactly how long this is going to take to transfer. In this case, 10 gig file on 100 megs, it's going to take you about 14 minutes. And that's anywhere going across the US or to Europe or even to Asia. It's going to be consistent. Now, the protocol scales linearly with bandwidth. So if you're able to increase that bandwidth from say 100 megs to a gigabit, that 10 gig file will now take only 80 seconds. It's going to be 10 times faster. The way that Aspera is deployed in a cloud environment is the server software is running on a virtual server in the cloud, and then it's connected into backend storage. And this server can run as a standalone in your own VPC, or it's available as a managed service from IBM in most of the popular public cloud platforms. So certainly IBM Cloud, but also AWS, Azure, and Google Cloud Platform. But even with the managed service, you can connect in your own cloud storage. So you could plug in your own S3 bucket. Now, the way that it works, data is transferred to the server, and then it's written directly into that backend storage. So it stays in memory in this server. It's not written to local storage first and being copied. It's getting uploaded and written right into that backend storage. Anecdotally, we have customers that are getting over 5 gigs per second sustained on a single instance, but you can pool multiple instances together and increase your overall speed. So Aspera on Cloud is the name of IBM's Aspera managed service. And this application allows you to control multiple Aspera servers. And that includes the hosted service from IBM that I mentioned, but also standalone Aspera servers that are in your own cloud VPC, or even an on-prem server running your own private data center. Now, as an admin, through this interface, you can manage the transfer node policies right through this web UI on all of these different transfer servers. The other thing you can do is you can initiate transfers through here just through a simple drag and drop. So for example, I could take files from my on-prem data center, drag it up into an S3 bucket in Amazon right through this web interface and initiate that transfer. Okay. Before I turn it over to Jason for a live demo, I wanted to highlight a couple of projects that we've worked on here at BackGen. The first is a large Hollywood studio that was consolidating multiple data centers and needed to move an archive in a fairly short window of only about 45 days. We worked with them to stand up Aspera servers on-prem and then also on Amazon. And rather notable, in this project, we got a sustained 17 gigs per second going right into S3. This is a huge archive, it's about 6 petabytes, but we were able to complete this migration in under 35 days. The second project we worked on is with a large video game company. In this case, they were migrating data into two cloud providers, AWS and Google. A key requirement here was they needed to maintain a sync of the two storage repositories between clouds, both during and after the migration was complete. So this is a good example of how a lot of migration projects are not a one-time event, but really more of this ongoing project that can last months, or in this case, years. It's still running right now. Using Aspera, we're able to help them both with the migration, but also this long-term synchronization. So with that, I'd like to introduce my colleague, Jason Warman, who will walk through a couple of demos of using Aspera into the cloud. Jason?
Thanks, Mark. Let me go ahead and share my screen out today and start with the live demo of the Aspera software. I'd like to show a couple of different use cases to give you an idea of, not only the sense of the technology that Mark's been describing, but also what some of the different options are as far as workflow go. As Mark mentioned, the underlying technology behind Aspera is really that unique protocol, the FAST protocol, and the suite of software that's available around it are designed to implement that protocol in different ways to fit into the workflow. Whether it is more end user based, where somebody's coming in through an interface to transfer files, or something a little bit more automated, where you can set up a pipeline to automatically migrate data in between clouds or up to the cloud. So to begin with, I'll start with a simple sort of on-prem to cloud type of data movement. First, just as a sort of contrast, I'd like to use a tool that some of you may be familiar with. This is Cloudberry to interact directly with S3. This is a pretty sort of straightforward HTTP style uploader where you can interact with S3 storage. I just want to make sure that my bandwidth is set to unlimited here. Yep. And it is a pretty sort of straightforward interface. In this case, on the left-hand side, I've got a local 5 gig, in this case, movie file that I'd like to upload to this S3 bucket on the right-hand side. Now, my Windows server happens to be in Northern Virginia that I'm on right now. I'm transferring to an S3 bucket in US West in Oregon. So let me go ahead and just click copy. This is pretty straightforward. As I said, this is a single 5 gig file that's being uploaded. One of the first sort of stumbling blocks you'll notice is the setup time for this type of transfer. As the tool does hashing and starts chunking up the source files, there's quite a bit of a wait until the actual file transfer itself even starts going. So, if you can imagine this with even larger files or large sets of files, it really is sort of an additional bottleneck even before we get to transferring. Now, in this case, you can see at the bottom, I've started transferring this single file. It's going to take about 35 minutes, right? So again, even a single 5 gig file and not a very large file or a very large set of files, you can see how this is going to take quite a bit of time, even without encryption or any other hindrances on the network. So let me go ahead and cancel this. I'm not going to make everybody wait through a 35-minute upload. But to contrast with that, I do have an Aspera server installed on the same machine. So this is sort of the core server-side engine from Aspera. It's called the IBM Aspera High-Speed Transfer Server. Now this is available on Windows, of course, as I have it here. It comes with a nice GUI. It's also available on Mac and Linux. In this case, a very similar sort of setup, right? I have my local file systems on the left-hand side to browse through. I've got a couple of different Aspera servers configured on the right-hand side, including my S3 bucket. Right? You can see this one happens to be using in AWS US West 2, an Aspera on cloud instance, right? So this is the SaaS version, the managed service that Mark was mentioning earlier, where IBM Aspera is running the compute instance on their customers' behalves, and this is just my own S3 bucket that's attached to it. So I'm going to connect in, and then I will kick off an upload. You can see it retrieving the directory listing here. Now, once I click on upload, this is going to, again, get this 5 gig file directly to my S3 bucket. You can see a little bit of detail down at the bottom of the screen. And in fact, if I click the details button in the upper left-hand corner, we can take a little bit of a closer look. Now, I'm on a 1 gigabit circuit, but it is shared. You know, I have other servers in my data center that are using the same 1 gig. You can see some of the network statistics on the left-hand side here, including the packet loss, which fortunately is below 1%, but you can see that round trip time. That's the network latency that Mark mentioned. So we're going coast to coast, East Coast to West Coast US over public internet, and I'm seeing somewhere between 80 and 90, 95 milliseconds of latency. You know, that's the type of network condition that really hinders those traditional FTP or HTTP style transfers. In this case, though, you can see my 5 gig file is making quite a bit of headway. There is, by the way, automatic retry and resume in all of these Aspera transfers. So even if you have a network disconnect in the middle of a session, it'll pick back up wherever it left off. In my case, though, that's not really a problem. You can see that one 5 gig file that was going to take 35 minutes with a native uploader took me just over a minute using the Aspera tools. So again, this is a very straightforward sort of single file, in this case upload, but this is really the power of Aspera, right? This same set of software, the transfer server on my source Windows box here, and then the Aspera transfer service from Aspera on cloud in front of my S3 bucket, you can use this for any set of files. There's no limitations on the number of files or the size of any file, as long as that underlying object storage supports it. And there are many different ways to sort of implement this. So it's sort of nice to look at the GUI, especially on a demo like we're doing in the webinar today. But in this same software package, there's a very straightforward command line option, so you can script this up to do uploads and downloads. There's also a RESTful API available. So you can make REST calls from another part of your workflow that trigger the same Aspera server-to-server transfer with all of the same underlying characteristics. You know, the speed, that performance aspect of the Aspera protocol, along with the encryption that's done automatically, and the reliability behind it. By the way, I think we mentioned this earlier, but if anybody does have questions as I'm walking through this, please feel free to pop them in the Q&A section of the Zoom webinar. We'll be answering those after the rest of the demo. Okay, well, I'd like to switch gears a little bit here and show a couple of the other options available specifically in the Aspera on Cloud platform. So as a reminder, Aspera on Cloud is the SaaS platform that's available from IBM Aspera. And it sort of comes in two different halves, you can think of it, right? So the first is this web interface that gives you administrative control, like I'm looking at here, as well as a user-facing experience where end users can come in through a regular web browser to do uploads and downloads from their local workstations to your various cloud providers and cloud object storage buckets, as well as move data in between those cloud storage providers. In this case, I've started out here in the admin section of Aspera on Clouds just to sort of level set and give you a little bit of a orientation here. You can see in my PacGenesis Aspera on Cloud organization, I have 3 different nodes. And really a node is an Aspera endpoint somewhere in the world that's attached to my organization. And you can see I have them listed down below. This is one of the really powerful hybrid type of benefits to the Aspera on Cloud deployment strategy is that you can have this single interface and attach storage from really anywhere in it. So in this case, I've got this top node is IBM Cloud Object Storage that's hosted by Aspera. So this is a fully managed service attached to IBM Cloud Object Storage on the back end. Moving to the second one, this is actually a Linux server that I am self-managing, right? So this is in a Pack Genesis data center, in this case in Austin, that just has regular NAS storage attached to it. This is powerful, of course, because I'm really exposing some part of my on-prem storage through this SaaS front end. And we'll show you what that means for end users in just a minute. And finally, this third node that's listed out here, Oregon S3 customer ingest. So this is an IBM hosted Aspera server that's attached to my customer-owned S3 bucket. So in this case, I have an IAM role in my Amazon account that allows the Aspera servers the appropriate read and write access to my S3 bucket. That way, I'm in charge of my storage. Aspera never actually touches the storage itself, but I don't have to directly deal with the infrastructure of the compute instances that are running the Aspera server software. And now that I have all three of these storage nodes available, I can make them available to end users to upload and download even through a single web browser. Now, to that point, let me switch over to one of the user-facing applications in Aspera on Cloud. There's a ton of different features here in AOC. I'm not going to go through all of them, but I am going to switch over to what's called the Files application in the upper right-hand corner for AOC. And this is really a pretty straightforward files and folders type of interface that you can provide to your end users. Now there's full authentication and authorization support for Aspera on Cloud. It includes an IBM ID option that you can just type in somebody's email address to provision users. You can also hook this up to Okta or ADFS or any other SAML 2.0 provider if you'd like to keep your user management in your own organization. Now from there, as an end user, I can only see the files and folders that I've been granted explicit permission to. So even though I've got dozens of folders on my 3 different Aspera storage nodes, my particular user account's only been given access to 3 of these. You can see I've sort of named these appropriately to reflect that each of these happens to be in different locations around the world, right? So this AUS incoming, if I go to info here, you'll see the URL at the bottom. This is my self-managed Aspera server in my own Austin data center. On the other side, for Oregon Project 1, if I go to info, again, we can see this is the Aspera managed service in AWS and US West 2 in Oregon. So this is my S3 bucket. From an end user perspective, I happen to know where these are because I looked at info and because they're named appropriately. But you can see how powerful this is to just give your end users access to folders, and to them it really doesn't matter that this one happens to be in Austin, this one happens to be S3 in Oregon. They just see the files and folders that you've granted them permission to. Now, if I wanted to actually upload data, I can come into, for example, Oregon Project 1 and upload via my regular web browser. So again, this is pulling down this directory listing from my S3 bucket via the Aspera on Cloud interface. Now, we've been talking about the Aspera on Cloud, or I'm sorry, the Aspera Fast protocol. That's still in effect, even though I'm coming through a regular web browser, right? So if I want to upload a folder full of data from my local workstation here, let me just go to, or let me grab just a couple of files. I think that'll be easier. Grab some of these photos and click open. This is now uploading, you can see in the upper right-hand corner, directly from the workstation into my S3 bucket. It's using that same Aspera protocol under the covers, so we get all the benefits of performance, security, and reliability that Aspera makes available through server-to-server transfers, even though I'm in a standard web browser with this free web browser plugin that implements the Aspera protocol. So you can see this is a pretty straightforward way. Here's my JPEGs that I just uploaded showing up here of providing ad hoc end user access to cloud storage or on-prem storage anywhere in the world through a single interface. Now, Mark mentioned, we see a lot of customers that have challenges or just business requirements around working with multiple cloud providers. There's also a nice option here in Aspera on Cloud that lets you do those migrations server to server. Right, so my marketing assets folder happens to be in IBM Cloud Object Storage. If I look at it here, this is in the Dallas data center for IBM Cloud. I can dive into marketing assets on the left-hand side. I've done a little split screen here. I can look at my Oregon project, that's my S3 bucket in Oregon on the right-hand side, and I can copy files directly between them. So if I want to grab, let's say this Aspera, an IBM company logos folder that's sitting in IBM Cloud Object Storage and get it from the IBM Cloud into the S3 Cloud, I can do that with a simple drag and drop. You can see the status here, copying files. And of course, this is really the powerful part of it. As I said, this is moving directly from IBM Cloud to the AWS Cloud without having to have any intermediary, right? I'm not downloading these to my workstation just to re-upload them. It's a direct cloud-to-cloud transfer. So for those of you that have multi-cloud strategies as part of your BC or DR type of strategy, this is a very powerful tool. This is also available, by the way, via API. In fact, anything that I'm doing in the Aspera on Cloud interface here is also available via API, right? So it's nice to have this option for end users to move data interactively through the web interface. At the same time, a lot of folks are wanting to make sure that as they move to the cloud, they're doing everything as code and making sure that there are automation options available so that they can do these type of operations as well. One of the interesting things here is that each of the cloud providers, of course, has its own set of APIs. Adding Aspera on Cloud on top of that sort of abstracts that, right? So if you're doing a send-or-receive in between IBM Cloud, AWS, Google Cloud, Azure Cloud, you don't have to change your API calls for the specific object storage for each of those vendors, right? You can make a single API call to the Aspera on Cloud platform, and it handles everything under the covers for you. Okay, so that's sort of the basics around the Aspera on Cloud interface and the Aspera on Cloud and on-prem integration that I wanted to show you. Hopefully that was useful for you. Now we did want to save a little bit of time here for Q&A. So let me bring Mark back in and see what kind of questions we can answer for you.
Okay, let me go ahead and thank you for that, Jason. So it looks like we have a few questions that came in. I'll let you answer this one. Does Aspera support AWS Glacier?
Yeah, definitely. Actually, it's a great question. For those of you that aren't aware of it, Glacier is sort of that long-term storage available from AWS. It's super low cost, which is great for these sort of cold archives where you want to keep some of your assets in long-term storage. Now the APIs for Glacier aren't great for doing high-speed transfers into them, but what we do with a lot of our customers is use the native AWS lifecycle options with their S3 buckets, right? So in a typical case, we'll put in a lifecycle option for a specific folder within an S3 bucket, and anything uploaded there via AOC or elsewhere will automatically be shipped off to Glacier. One other thing around that, and not to get too deep into the weeds here, there's also an automation platform within Aspera on Cloud that lets you do some file and folder movement automatically behind the scenes. So we also have a customer, we were just working on this last week, by the way, where incoming assets get copied into two different locations. One is into Glacier for archiving, and then the other is into another folder that's used for the rest of the pipeline for downstream processing.
Okay, looks like another question here. We get this all the time. How is Aspera priced? I can take this one. So there's basically two pricing models with Aspera. There's a perpetual license, which is sold on a per server basis, or a consumption license that's sold based on the number of bytes that are transferred annually. Now, depending on your use case, we might recommend one over the other, or maybe a hybrid of both. I'd encourage you to set up a call with us, reach out separately, and oftentimes we'll work with customers to really understand the requirements, and then we can figure out which licensing model is most cost effective. Looks like we've got one more question here. Jason, does Aspera work with storage other than S3? That's a good question.
Yeah, so the SaaS model for Aspera on cloud is geared towards object storage because that's easy to handle across accounts. But certainly if you're running your own Aspera server in your own VPC or in your own cloud object or cloud storage or cloud compute environment, you can attach any kind of storage to it. So we have customers using, for example, EFS or EBS directly attached to one of their managed Aspera nodes.
Okay. That looks like all the questions that we have. I want to thank everyone for joining our webinar today. If you want to learn more about Aspera or discuss maybe a particular use case, please visit us at pacgenesis.com. We'd love to talk to you. Thanks everyone for joining.